Hey everybody, I'm going to give you a quick tutorial on how to do an estimate of the acceleration of an object like a basketball that's being shot. So here's a video, and what I did was I found this video on YouTube, and by hitting the comma and the period button, you can go frame by frame. So you can actually see all the way down to a 30th of a second the positions of these things. And I looked at this video, and it looks to me like it took about, just by going frame by frame, it took about 8 frames for him to shoot the ball, right, to get it up to speed. And then the time that it was in the air, I think, was about 32 frames, just by going frame by frame. I looked up the distance for a basketball court, and it's roughly 22 feet. All right, so that's something like 7 meters. Again, it's just rough estimates. And I'm not even going to take into account the vertical motion of the ball. I'm just going to think about the horizontal motion of the ball. And it took 32 frames to go roughly 7 meters. All right, so if I'm thinking about the velocity that the basketball player gave to the ball, then the key thing to know about the frames too is that I actually went through and I clicked and I counted how many frames were there in 1 second, because you can look at the clock at the bottom and see how many frames in 1 second. So that's 1 second divided up into 30 frames. So each frame is roughly 0.03 seconds. And then since this took about 32 frames, then I know it's about 1 second. So I'm just going to round it off to 1 second. Again, we're estimating. The ball went about 7 meters in 1 second. So that's my velocity. That's the final velocity I'm dealing with. Right? So using the frames and the distance that I know to find out what the velocity is. Now I'm taking the final velocity, the initial velocity I'm taking to be 0. And he's shooting it, so he gets the ball roughly to rest very briefly, and then he shoots it. And that takes 8 frames. So I'm taking 8 frames, so I would do 8 times 0.03 seconds, and that comes out to 0.24 seconds. Right? So the ball goes from 0 meters per second to 7 meters per second. So the initial velocity is 0 meters per second. The final velocity is 7 meters per second. And the time it takes to do that is about 0.24 seconds. Again, how did I get the 0.24 seconds? I said 8 frames, and each frame is 0.03 seconds. So 0.03 times 8, that gives me 0.24. Right? And if I want, I can even round that to 1/4. So I'm saying 7 meters per second divided by 0.24, or roughly, right, 1/4 of a second or so. And that gives me an answer of 28 meters per second squared. Okay. It's a very rough estimate, but it is an estimate for the acceleration of a basketball while it's being shot for a 3-point shot. Again, quick review. I go frame by frame. First of all, I figure out how many frames are in a second. I get 30 frames. That means each frame is 0.03 seconds. 2 frames would be 0.06 seconds, etc. And then I click through by hitting the period and the comma, count how many frames there are, and then I get the how many frames are in the time it takes to shoot and the time it takes to hit the basket. I need the time it takes to go to the basket because that's the velocity. I find out the distance, so distance divided by that time gives me the velocity. That's the final velocity. The initial velocity was 0 because he was shooting it roughly from rest. And I find out that it took about 8 frames for him to get it up to speed, to accelerate it. So 0.7 seconds, or 7 meters per second, divided by the time it took, roughly 1/4 of a second, or 0.24 seconds. And then I get roughly 24 meters per second squared. Okay. So good luck with your estimate. And you can use the frame by frame feature to help.